Hey guys, we're Group 4 and we're going to teach you about two main concepts on rotational motion, angular velocity and torque. Here's a riddle you might have heard before. When a record spins, does the edge of the record spin faster than the center of the record? This riddle seems impossible at first, but with a little physics knowledge, we can answer it.
First, you have to understand there are two kinds of velocity, linear velocity and angular velocity. Linear velocity moves in a straight line and can be defined as the radius of a circle r, multiplied by the angular velocity, omega. But what is angular velocity? Angular velocity rotates around a fixed axis and can be defined as an angular displacement, change in theta divided by change in time.
So, to return to our record player riddle, we can say that the angular velocity is the same no matter where you are on the record. Think of it like this. No matter where you point along the radius on the record, it's going to take the same amount of time to cross the angular displacement. The record is a rigid object, so that makes intuitive sense. And if angular velocity is always the same, then, as you can see in our equation, that means linear velocity has to be largest when the radius is largest. As radius increases, the linear velocity must increase as well.
So, the answer to our record player riddle is that even though angular velocity is the same everywhere, linear velocity is the largest at the edges of the record. Now, we're going to talk about the other main concept from this chapter, torque. To start us off, let's ask another riddle. Why is it easier to lift your textbook cover from the far end than from the end closer to the binding? The answer has to do with torque. Torque is the product of force, such as the force applied to the book cover by your hand, and the lever arm, which is the perpendicular distance from the force to the axis of rotation, aka the book binding.
We can model torque with this equation. T equals R, the lever arm, times F perpendicular, the force. Notice that if the force applied stays the same, then as the lever arm increases, torque also increases. The bigger the lever arm, the bigger the torque, and the more bang for our buck we get with our force.
But what if the force is at an angle? That's no problem. All we have to do is find out how much force goes in the x direction and how much goes in the y direction. The sine of the angle here will tell us how much torque is applied by the force.
And now you've learned two very important concepts about rotational motion.
Can you think of any examples of torque or angular motion in your life?
Let us know in the comments.
Thanks for watching!